Okay, moving on to question 2. The enthalpy of vaporization for acetone is 32 kilojoules per mole. The normal boiling point for acetone is 56.5 degrees Celsius. What is the vapor pressure of acetone at 23.5 degrees Celsius? So to answer this question, we would need to use the Clapeyron equation. So basically, it can be summed up as ln of P2 over P1 is equal to the delta H of vaporization over R, which is multiplied by 1 over T1 minus 1 over T2. Okay, so let's look at all the values that they gave us. So R is the gas constant, and it is 8.314 joules over mole times K. So T1 in this question would be the 23.5 degrees Celsius. So I'm going to convert this to Kelvin since I want it in the same units as my R. So converting this to Kelvin would be 296.15 Kelvin. T2 for this question would be the boiling point of acetone, which is the 56.5 degrees Celsius. And again, I'm going to convert to Kelvin by adding 273.15 to get 329.65 Kelvin. Okay, so we also are given the enthalpy of vaporization. So this is the delta H vap, which is 32.0 kilojoules per mole. But again, if you look at my R constant, its value is given in joules, so I'm also going to convert this to joules by multiplying by 1,000. So you end up getting 32,000 joules per mole. Okay, so we are looking for vapor pressure. So P1 is equal to question mark. And we assume this started at standard pressure, which is 760 torr. Okay, so I'll just put in brackets standard pressure. Okay, so now we can put all these values into the equation. So it will be ln 760 torr over P1 is equal to 32,000 joules per mole over R, which is 8.314 joules over mole times K. Then this is multiplied by 1 over T1, which is the 296.15 Kelvin, minus 1 over 329.65 Kelvin. Okay, so now if you plug all these values in to the calculator, you want to make sure you do what is in brackets first. So I would personally do the 1 divided by 296.15 separately, and then minus bracket 1 divided by the 329. And then after solving for that is when I would multiply it by 32,000 and then dividing by the 8.314. Okay, so let's simplify the right side. Plugging that all in should give you 1.321. And to get rid of the ln, we are going to do e to the power of both sides. Don't know what that's like called, but e to the power of 1.321 gets rid of the ln on the left side. So if you were to solve for that, it is 3.75. Then I'll write P1 is equal to 760 torr divided by 3.75, and this gives us a pressure of 202.9 torr. Okay, so let's see what the junior tutor said. Clausius-Clapeyron equation relates the vapor pressure, enthalpy of vaporization, and temperature, where R is equal to the ideal gas constant. If P1 and P2 are the vapor pressures of two temperatures, T1 and T2, the equation takes the form ln P2 over P1 is equal to delta H vap over R times 1 over T1 minus 1 over T2. Okay, so they also show the conversion to Kelvin for our temperatures. And P2 would be standard temperature, 760 torr. Substituting the values to the formula gives us this. So they did the same approach and ended up getting 202.87 torr. Okay, so the solution is correct. Okay, so now let's move on to question number 3.